Welcome to Study Loop.
Okay, we're looking at question 28.42. We have a long solenoid and we're given the magnetic field that we want for the center of the solenoid, and we're asked to find the current. So over here on the left, I've listed the information that we have. We're given that we want the magnetic field, the number of turns, the length of the solenoid, and I've converted the length into meters. The diameter, also converted into meters. Of course, our mu naught, we always will need to know. And we're, again, trying to solve for the current here. So to do this, we want the formula for the magnetic field of a solenoid at the center of the solenoid. And that's mu naught times little n times I. And remember, our little n is going to be the number of turns per unit length. So to calculate that, we do the total number of turns n divided by the length L. So luckily we have both capital N and L, so we're going to be able to determine n. Now, if we plug that into our formula here, just put that in like this for us. Remember, we want to solve for I. So before we plug in numbers, why don't we just rearrange this equation to give us I. So to do that, we're just going to divide both sides by mu naught and then multiply each side by L over N. So we're going to get B times L in the numerator, and that's going to be divided by our mu naught times capital N. So this is what we're going to calculate. We know the value of B, that's going to be 1.5 Tesla. The length is 0.55 meters. We know our mu naught over here. So that's going to give us this. And then our number of turns is 4,000. And when we calculate this, we should get that the current that we want is 41.8 amperes.